of all, I wanted to thank everyone for joining this webinar, an introduction to digital product passports. I'm Elena Fernandez. I work for UNITAR, the UN Institute for Training and Research. And as part of the Circularise project, we're developing a number of learning and training material, including this webinar. Today we have with us Daniel Gregory, who works for Circularise, which is a DPP provider that is part of the Circularise project, and he's going to share his expertise with us. So, Daniel, the floor is yours.
Fantastic. Thank you very much, Elena. And it's thank you all for joining on Monday morning. What I'll be doing in the next hour is going over the kind of an introduction to what a digital passport is, how you can think through what it is, maybe a couple strategies on how to approach preparing yourself for making one of them if you want to do that, and some case studies on how we've built them at Circularise, and kind of demonstrated their utility beyond, say, some of the regulatory compliance aspects that people most frequently associate with them with. Before any of that, though, I will jump in and give an introduction on Circularise and on Circularise as well. To give that general introduction, essentially, Circularise is a project funded by Horizon Europe. It's essentially, so if you think of the EU as in the process of transitioning from a very linear fossil fuel intensive economy to one that is more based on renewable energy, it's more circular, and it's supported by a lot of digitization. However, essentially being able to do that requires taking on several critical, it requires the use of many critical raw materials, which are generally not readily available in Europe. But they're in a lot of different electronics and electronic devices like phones and laptops, but also solar panels, data centers, wind turbines. They would be available within Europe if we were able to properly recover them from different waste streams. This is a concept often called something like urban mining. And in order to support that, the EU is developing this critical material strategy with the goal of improving supply chain resilience, but also at the same time supporting sustainability and circularity. There we go. The digital product passport, essentially, in order to do this, we need to know where to find the critical raw materials. One tool that's being helped to develop this, or that's being used to create this, is the digital product passport, which is a record detailing the life cycle of the product, including its origin, composition, environmental impact, and allowing for exchange of information across actors in the value chain. So being able to couple the digital information about a material with the material itself as it moves through that supply chain. The goal, or kind of the vision of Circularise, is to accelerate these different circular economy practices. So once we have this digital product passport, what can we do with it? And what can we do with it specifically to enhance that material efficiency, to reduce the environmental impacts, and contribute to that more equitable, resilient, and sustainable society? The goals and the way in which they're doing this are to develop a resource information system, integrate that DPP system, or integrate the DPP into that resource information system as kind of the main structure of that information system, and then add in supplementary data or supplementary insights on top of that digital product passport to make it even more powerful and useful for the people in the economy making those sustainable and circular decisions. And we want to try and then make that additional kind of that extra value as open access as possible to support all of these different features. In terms of, we want to try and, how does that work? Essentially, we want the manufacturer to take in the DPP or we want the manufacturers to make the DPPs, and then they can use the Circularise system to calculate both re-indicators. So these are different circular strategies like recycling or remanufacturing or reuse, as well as SEE indicators. These are societal, economic, and environmental indicators. Think of like a life cycle assessment, understanding the impact from a carbon, like how much carbon was used to make the material, but also now social impacts like were there fair labor practices or unfair labor practices at different points in the chain. We then, once it's in its use, we want to then be able to add to that digital product passport, gather some more information and structure it in the use cycle, improve that, keep gathering the extra information, and then have the Circularise system help figure out whether or not it's an informed purchase. Are you purchasing the right thing as a consumer that aligns maybe with your values on these different aspects? And most importantly, are you informed about how to dispose of this material at the end? And then the person using it at the end of the life cycle, or at the end of the life cycle, at the end of life, can understand how they need to handle it and use it from there. So how do they process it? How do they handle it? That then allows us to pick the right strategy for reintegration and circularity. That then allows us to then kind of update the DPP and send it back into the economy from there. In order to do that, Circularise has also developed 5 different indicators. So there's the reusability, essentially 5 different indicators of how circular a material is. This has been developed by EMPA in Switzerland, amongst many other people, but they were the bulk of this work. And it kind of demonstrates, essentially how stakeholders, helps stakeholders to understand how easy it will be to reuse, repair, refurbish, remanufacture, or recycle a product, and therefore which of those options to choose. To test all of this, we have 5 different case studies running. We have heating systems provided by Wiesmann. We have ICT products, so think laptops, different laptops and phones, provided by different refurbishment and remanufacturing centers, notably Ricosi, Green IT, and EcoReset, spread across Europe. We have Lexmark providing us with printers. We have Rossi in France providing us with PV panels at their end of life to understand how to better deal with those. And then a cluster, the EDI cluster, helping us with different batteries and how to understand this from a battery perspective. So now that we know a little bit of what that resource information system is, I'll move on a little bit to what Circularise does. So Circularise is a supply chain traceability platform. So we connect different data across supply chains in a way that gives the data owners control over who sees that data. So if you think back to the Circularise system where you're going from the manufacturer through to the user, through to the end of life processor, giving each of those people the access, or giving each of those stakeholders access to data, and the ability to add their own data to that thread of like the history of the product in a way that they maintain ownership of that data. We operate on a method that allows, or it uses a mass balancing system. This ensures that there's no double counting of materials. So we're really tracking the materials at a mass level, so per kilogram of material. And then as a result of this traceability and the insight, like being able to connect all of this data through the supply chain, we then also organize that data into digital product passports. So being able to share and organize all of this information in a way that is standardized and helps everyone be on the same page. The goal of this is to see a world, or create a world, where there's no material that is wasted due to a lack of information. So really being able to connect people, really line up with the goals of the Circularise project, and to that end, Circularise is providing the digital product passport services to connect into the Circularise system, and working with the use case partners to develop those, for example. Having now explained a little bit about both the Circularise project and Circularise as a whole, I think it's probably good to look at what exactly is a DPP. We've mentioned a digital product passport numerous times, but I haven't really kind of gone into that at a really basic level. We'll then look at some of the requirements for the DPP, the structures, and some fundamental IT management, and then some impact on business and industry. There we go. So the purpose, or a good way to think about this, or starting to think about this, is the idea of net zero and circularity claims. There are a lot of them going around. They're oftentimes very well intentioned, but they're also equally very, very hard to verify, especially for an individual consumer. It makes for fantastic marketing material. As you can see, maybe you even, depending on where you work, your institution will have its own net zero goals, but it's very difficult to track how those are going. And you can see that by people continually pushing them maybe slightly further back over and over again, or refining them when they realize that maybe they overpromised and they need to revise before they underdeliver. The general problem, and the reason why that tends to happen a lot, is that data sharing tends to be very inefficient. It's very hard to share data across the supply chain, especially when people in that chain don't want others to know who they are or what they do, which is frighteningly common in most, if not all, supply chains. So you have this very difficult, it's very complex to create that kind of collaboration. It's very you have all of these different IT infrastructures that need to talk to each other. It's quite difficult. Gathering data from those is hard. As a result, it tends to be, or a lot of the time we see that kind of the default mode is sending people PDFs via email. This is a great way to tire everyone out and get them really annoyed. And so you end up with different vendor fatigue. You end up with disconnection because no one wants to share who their supplier is easily, or it's very difficult to kind of get visibility beyond the immediate people in your vicinity in that supply chain. And it's very difficult to scale this. It's time consuming, it's error prone. In order to solve all of these errors, you often use something like NDA or non-disclosure agreements to make sure that people can talk between different supply chain or between two different people, but those are always bilateral. So it's very difficult to set up very difficult to get that across the supply chain for multiple different things, and then even harder to keep track of it. The result of that is a very low trust system. There's a lack of verifiability, and oftentimes as a result, there's very little sensitive data protection in those situations. Like, you can send someone an email, and as soon as you send them that email, you've lost control over who they send that email and whatever was attached to it. You don't control who they send that to anymore. So it's very difficult to agree on what information to send and who to send it to. This is where something like a DPP can come in. And the best way that I find to conceptualize this, that I would say is probably the key takeaway of this talk, is that the DPP is kind of like a digital bookshelf. It's a way for you to, it's kind of just a vessel or a shelf where you can put a lot of different kinds of data. So yeah, you can add your data to it. You can, someone else can add their data to it, kind of in the form of a book or just a long list of data points, or however you want to structure it. And then it will hold all of those books and data points so that they can be read by the person who needs them at a different point in time. And as different people add things to the supply chain, because it's a digital bookshelf and it can do many different things, it will organize and restructure all of those different books so that all of the right information is there for the person who needs it at the end. You can throw pretty much anything you want into this. It really depends on who's creating the digital product passport and how good their IT system is. But pretty much any file will work. Like most sizes will work. Depending, yeah. It's a very flexible system. And then that allows different people at different parts of the supply chain to take the information that they need and use that to make a good and important decision on how they want to interact with that product, ideally in a more circular and more sustainable manner. I'd say that's really the important part here. In terms of, essentially you want to pair that bookshelf and that digital product passport. That's all virtual. You want to then connect that to the DPP in some way, shape, or connect that DPP to a physical product in some way, shape, or form. That is normally done with something called a data carrier. So this is essentially something that you can read the data from that can be attached to the physical product. You have stuff that can be engraved on a surface or printed. These are things like watermarks, barcodes, or QR codes. So those work relatively well. They generally need a line of sight and they generally need to stay undamaged, but they are extremely cheap to produce. And so it's really easy to put them on different things. For example, it looks like the battery passport, which is a digital product passport for batteries coming in from the EU, will be using a QR code for that purpose. If you wanted to get a little fancier, you can use something like an NFC or RFID, or maybe even a Bluetooth tag to allow sensors to pick them up through radio signals. So this doesn't necessarily require a line of sight. You can scan it with a kind of a test pulse, and then it will take back. It will read, like you can ask if there's something there, and it will read the information back. This is, for example, how contactless cards work in a banking system. So that's a different option for that. A third option is also then material tracers. So this is essentially something that is integrated into the material itself so that a chosen characterization technique produces a unique fingerprint. So like you can scan it with a particular sensor and it will give a very unique profile to that material. And it's only that material that gives that profile. And then you can link that to the rest of the passport, essentially. So lots of different options for the carrier. There's also a number of different kinds of application levels for this, because if you think about it, a product is relatively difficult to, or like there's a number of different ways that you can classify what a product is. So once you know how to carry the data, you need to figure out where you're trying to carry it. That depends a lot on the regulation for the industry, and most of those are still in development. But generally, there are kind of three different levels to that. There's the unique ID. So this is kind of the asset itself, like a specific computer, a specific car, something that has a specific serial number that is unique to that asset itself. A little step down, you have a batch, which is a large number of assets or larger than one, that are all made under the similar or the same conditions. Think made the same day or made on the same production line within a certain window of time. Then slightly above that, you have something like the product model, which is something like either a stock keeping unit or a global trade identifier number. This is like the model of a computer, like or the specific make of a car. It doesn't necessarily have to include all of the different customization features that you have with that. It's just it's a way to say like it's a way to give a specific kind of product. So many assets from many batches can share the same product model in a sense. Yeah. In terms of how kind of all of this fits together, Circularise has a sister project called Surpass that has I think this is a relatively useful visual on that. The idea is that you have all of these different stages of the manufacturing. They are all producing products themselves. Those can have digital product passports in and of themselves, and then those combine together to create something from the manufacturing stage that moves on to the that then gets used, and then as it gets used, and there are different kinds of circular economy systems, the information or essentially you have this digital information flow, which is represented in the blue lines down here. Different things can travel from the manufacturer into this kind of data exchange layer, where the digital product passport, the kind of like this section here, is your bookshelf, where everyone is providing a little bit of information to the bookshelf. It gets organized. It becomes more useful than it was originally because it's organized and it's contextualized with everyone else's information. And that allows people to make very good decisions on how to then reuse this physical loop of materials represented in yellow here. You're kind of being able to draw, you can draw on the information from any stage of the supply chain and pull that into your system, or use that to make better decisions. To then have that linked across different, essentially at a larger scale, this is a very similar concept. You're taking each kind of, if you think of each different, each different step in the supply chain, someone producing something has a product, essentially. So each of those products has their own digital product passport associated with it. And that supply chain can be as arbitrarily large and complex as you want. But if you are passing the digital product passport from one step in the chain to the next step in the chain, as long as you're doing that in an organized manner, which is what all of these different regulations are trying to set up, then you can scale it indefinitely across all of these different things. You're just adding more and more books to the bookshelf, creating this little library for the product that allows you to then make as many good decisions as you want on that system. It's kind of like the end of Interstellar in a sense. You just have books upon books upon books. And while all of those lines that you see at the top, so you have all of these here where the authority, everything coming towards kind of an authority or a central regulation system, that ordinarily would represent rather a lot of paperwork for everybody. But with the digital product passport, you can digitize all of that, handle it all in the same kind of document. So it becomes much easier for both the people doing the regulation and also the people seeking to comply with the regulation. You don't need to go do the 100 different kinds of regulations. You just have everything set up in the digital product passport as well. So it can reduce a lot of the administrative work for pretty much everybody involved in the chain. So we've defined what the passport is, we've attached it, we've mapped out where it goes, what actually goes into it. Let's have a look at that. So here you're going to have a number of different kinds of data sets and a number of different kinds of sources for that data. So the kinds of data that you want to put in, the sets of different kinds of data, are going to be essentially information that is either required by regulations. So something like safety data, life cycle assessment data is increasingly becoming regulated, different kinds of due diligence, performance information. You'll have data requested by the value chain, so sourcing compositions, understanding where things are from, origin data, certifications, different kinds of identifiers for tax or customs reasons and different trade regulations. And then also you can also add information that maximizes the product value. So credits or certification, like voluntary certifications that prove that your material is or your product is better than someone else's. Information that helps you create take-back schemes, or allows you to kind of track where something is going so you can make better claims about what happens to your product later. Essentially a number of different kinds of pieces of data, who to contact in the case of an emergency or maintenance. You can upload, you can put in user manuals, different things like this. where all of that comes from depends a lot on what the product is, but essentially the majority of that is probably going to come from upstream suppliers. If you're right at the end, if you are upstream, then maybe slightly fewer people behind you, but that's essentially all of this data is kind of stored or created in different kinds of ERP systems like resource management systems, machines, and IoT data. So different kinds of sensors on say a production line or during the testing phase of different things. You have LCA models will create this, certification bodies will produce test results, and those test results have the data that you can then feed into the DPP, and different things like technical and safety data sheets. So all of these different places will have the kind of data that generally goes into the digital product passport for all of these different regulations. I'm going to skip through really quickly here, and then I'll go back because I realized I got the order a little wrong. A good example of this from the EU battery passports is essentially that there are a number of different manufacturer obligations. So something like a carbon footprint declaration with different classifications and thresholds, that's going to come from a life cycle assessment. That life cycle assessment is going to come from some LCA software. You could run that in-house, you could run that from a third party, but that's essentially where that data is going to come from. Understanding a specific percentage of recycled materials is going to have to come from or manufacturers will have to provide that from their supply chain. So they're going to be dependent on the supply chain data to show the origin of different materials, provenance, how it was made, how it was created, and showing that, for example, a certain threshold of that is recycled material. You're going to need to store that in a passport. It gets identified by some unique identifier. So something printed or engraved on the battery, that's that data carrier, likely to be a QR code. And then they need to show that exists. You need to have a document on due diligence. So being able to prove that you did the work properly in terms of how you organized and created all of this data, that itself can then be stored on the digital product passport as well. And different declarations of conformity. So proving that the battery is what you say it is and has all of the different characteristics that are claimed. So you have all of these different kinds of things that you might need from a regulatory perspective can all be stored on the battery and can all be found within the supply chain or within a manufacturer's operations. So knowing all of that, how do you start? Here, what you want to do is understand first what kinds of regulations a product needs to comply with. So if you are a product at the end going to the consumer, that can be relatively simple because you can't sell it on the market if it doesn't have certain regulation or you don't comply with certain regulations, and the data requirements for those are usually well known by the people selling the products already. If you are further upstream in the supply chain, it can help to try and understand where the product goes after that. So talking to some of your downstream people and understanding who else they work or where that product goes after you handing it to your downstream customer, and then seeing if there's a way that you can help to make those regulations a little easier to comply with from a data perspective. Once you know that, then you can do an inventory of your existing data. So knowing what do you have that's available, where is it stored, how is it stored, and how often does that update, who's responsible for it. So really kind of auditing and figuring out what your capacity is to manage and handle that data at the moment. Then you want to identify different data requirement gaps, or essentially figure out where the gaps are. Is there data that you need to provide that you don't have or that you're not tracking? And how can you fix that gap essentially? And then identifying, for that, if it's something that you can't produce, then identifying those responsible parties upstream, who has the data that you need, who needs your information downstream. So where are you filling in the gap for someone else further down? And then at the end of that, you need to figure out how you want to communicate that data. Do you want to create this DPP and pass it along as as that digital product passport, or do you want to try and pass it along as maybe PDFs work for you? Maybe there's a way that you can share it in different ways. I would highly recommend a DPP. So essentially, once you figure that out, you might be asking, this is a lot of work. How does it benefit me? You have all of this data on the left-hand side here that is necessary for a lot of different regulatory for a lot of different regulatory things, and making sure that you're compliant. But a lot of that is very valuable to the people downstream of you, or to customers, or proving different sustainability aspects. So there's value attached to this data, and there's value in organizing that so that someone else further downstream does not have to organize it for you. That is, and doesn't have to spend resources doing that. So just the act of being able to organize this information is already going to make it valuable and useful to the people downstream, which allows you to then build different relationships and kind of improve customer relations, essentially. It also allows you to comply with more materials or more regulations. So if you have all of this data structured, if a new regulation comes in or a new regulation is adjusted, you already have the structure that you need to be able to find that information really quickly. So it's a lot fewer resources, a lot less time, and a lot less risk to be able to adapt to changing regulations. The DPP also allows you to share things very quickly to new people. So can act as a new channel for sale. It can act as a new way to market or sell your materials and your products. Being able to say, hey, here's a really quick check on our performance perspectives. Here's how easy it is to disassemble and recycle our material. Like we can give you like different ways to demonstrate the value that you're adding. And most importantly, also looking back, you can then de-risk your supply chain. So you can say, if there are geopolitical events that are causing disruptions in your supply chain, you're not going to be blindsided by some choke point 4 or 5 tiers up where everything has to flow through and there's a sudden problem in that you didn't anticipate. You can see where there are risks, where there's a heavy dependency on certain actors or maybe certain countries or different things like that. And you can proactively avoid those or disperse them or minimize them before they become a problem. You're essentially buying the plunger before you need the plunger. So there's a lot of different benefits here. Yeah, functionally the same argument here. You have a lot of different information that allows you to meet regulatory requirements, but that allows you to then maximize that value. You can even create new, for example, new business models, like being able to create a way to build take-back schemes, maintain control of some valuable materials in your supply chain by making it easier for people to give that material back to you at the end, and then remanufacturing. That material stays in circulation. You don't have to do as much work getting it, and it creates a more sustainable and circular scenario in society. In terms of the data access and security, you may have noticed that there's a lot of data that people are asking for now. So what I'll try and do in this next section, which is the second half of this call, is the kind of an overview of some of the protection laws, some challenges maintaining that, and then developing that security. Like essentially, how do you think through who gets access to what data and the different kinds of methods that are available? Then at the end, a little bit of a security plan for that. You have essentially, there's a lot of compliance here, navigating a lot of different EU laws, and a lot of them feel very contradictory. So you have something like the GDPR, which protects a lot of personal information, and the Trade Secrets Directive, which shields a lot of proprietary data at a company or a business level, while at the same time you have something like the EU Data Act, where you are being mandated, or the EU is mandating that certain product data is required to be shared with the user of the product, and the ESPR also adds on different kinds of sharing environments or different sharing requirements. So what you need to then do is figure out how to navigate that conflicting balance of like being able to protect people's information or protect information that is sensitive, but also share information that is necessary and required. And that is very difficult to do across these complex and diverse supply chains. If you think of how difficult it was to understand the map of where all the data can go and what can happen to it, adding on this extra layer of protection is extraordinarily difficult. The way that this ends up being addressed in a lot of the regulations and obvious and kind of the current best practice approach is the idea of access control or selective sharing of the data. So depending on who has access to the information or who's looking for the information, different levels of access are granted to being able to see it. So something like public access would be very limited information, really just kind of proving that it's passed regulation or it's compliant with regulation, and maybe some interesting performance or essentially marketing materials. Then as you get more and more important, so role-based access in the supply chain, you could see a little bit more information. And then for something like an authority or the person who creates that data, they would be able to see pretty much everything to be able to perform the compliance audit or being able to actually work with your own data. And there are different ways in which there are different ways that you can conceptualize how much data you want to share. You could share absolutely everything. You could share a range, like somewhere between two different values, or you could just say, we're not going to share it at all. And that depends, like how you want to set and organize that depends a little bit on what your product is. Yeah, one of the key challenges for this is if you, and this was as said before, if you're trying to keep your data protected, if you're sending an email to someone else, you completely lose control over how the information in that email is then passed on to the next person beyond a nice little footnote in the at the bottom that says this is confidential, please don't share it. That may not stop them. You can then add more legal protections and say an NDA, which says these two people can share information, and if one of them breaks the confidential information agreement, there are heavy penalties on them. That generally works between two different parties, but it becomes really difficult at the scale of that supply chain that we showed earlier. How to organize or even just assign blame to who shared what information becomes very, very challenging. So the way that this generally is approached is through something like encryption and anonymization. And here you're essentially creating, like you encrypt it, you muddle up the data, you hide it behind a different, like lock it behind, like make it essentially unreadable or invisible, and then use selectively share how you want to. You selectively share it with people who have a different, or in a couple different ways. The three main ways I would say that you can do that are something like encryption access or key access. This is either a specific key attached to a specific person or an attribute. So if someone is in the EU and a recycler, they get access to certain pieces of information. If they are outside of the EU or not a recycler, they don't get access to all of that information or any of that information, as an example. There's direct data replacement, where you give them the original copy, but you redact a lot of the different, or you can give them something that looks like the copy, or the original, but it is a lot of redacted information, and then that hides the information that they're not allowed to see, but preserves the ones that they are, or it gives them a token that allows them to then access that information a set number of times if they're required, and they have to then validate. You have control over validating that token. You can then also create insights without actually decrypting it at all. This is maybe a more advanced level, but I think is a way that fully keeps the data, like the data never gets decrypted, so it's never visible and seen. Here you have things like being able to, or homomorphic encryption, which is essentially being able to run calculations on the encrypted data that then produces an encrypted answer that can be confirmed as correct, or zero knowledge proofs, where material, or essentially two people agree that something is correct without having to share any of the underlying information behind that. It's very interesting and difficult way to do it, but yeah, those are kind of the gold standards. In terms of different kinds of best practice, yeah, you want to, like, deciding once you've figured out how you want to share your data or encrypt it and have that selective disclosure, you want to then figure out how much you want to share with those different people. And here that depends a lot on how much you want to share and who you want to share it with. So being able to, like, kind of, I use this this table as a way to understand different kinds of the different levels at which you might want to share certain pieces of information. Like if there's, you could, yeah, share certain amounts of information with everybody, or it's easier to share more range proofs with everybody, different things like that. So understanding that in a sense, or figuring out how to conceptualize this, essentially you've created your DPP, you have your data. Now you want to develop a security plan. The best way to do that is to start by saying, what data do I need to share? And am I sharing the, you want to separate the ask that someone is asking about, which is an insight on your data, versus the request, which is the actual data itself. They might only be interested, like their interest is, for example, do I need to use a certain, I need to use a certain certain recycling method that requires that there's a certain threshold of material in here. So what they're asking for is whether or not they need to do the process, not whether or not you have the data. That gives them the information that lets them make the decision, but the decision is the insight, and the threshold is the data itself. Then you want to know who's going to receive that data, why do they need that, and then who else is going to receive that as a consequence. So what are they going to do? Like if party A receives the data, who are they going to pass it to? What else could that person do with it? And can it be represented in a way that A understands but not B? That might be a way to protect your data, or it's another way to protect the data. Then you want to think about what other data is associated, who shares that data, or yeah, who's sharing the data for me? Is this handled by employees or a third party? How are they trained to handle it? And how is that data encrypted and communicated? So how is it being shared? Is it scalable and manageable? Can I give it to A and make sure that A cannot pass it on to B without a way that that I agree with, essentially? So yeah, from there, I can give you a couple examples of how Circularise deals with this. Circularise uses a system called smart questioning, which is based on those zero knowledge proofs. So being able to prove that there's an insight associated with the data without revealing that underlying data itself. So the person who provides the information to the system gets to set all of the levels of data disclosure. They can say who gets to see this and how much they get to see. Within that, yeah, essentially, it gets, we gather all the data, we encrypt it, we store a reference of that encryption on a public blockchain, and then that encryption key that is on the, or that hash that's on the blockchain can then be used to selectively decrypt different pieces of information from the second company. I said the word blockchain. Oftentimes people don't know what that means. So the blockchain essentially is a way to get a network of computers to agree on what happened in a way that makes it infeasible or functionally impossible to go back and change that log. This essentially is normally used in financial, or can often be thought of in financial transaction terms, but you can also use this in different supply chain terms. It gives you a record where everyone agrees on how material passed from one stage of the supply chain to the other in a way that is very difficult or impossible for them to change later on, much like the physical movement of materials. It's very easy everyone can agree how something moved from one to the other as a physical material, and it's very difficult to go back in time and change that. What Circularise has been able to do in the past, or one of the case studies that we did with Samsonite, was they created a suitcase based off of circular materials, so something like used cooking oil and different things like that. And Circularise was able to trace all the way back through the supply chain, starting from the suitcase, the final product, going back into the components like the wheels or the handle or the case or the lining, and then working with those suppliers to figure out where they got their materials from, and then onwards and back, and being able to trace the whole supply chain back through to, in some cases, for example, the place where the used cooking oil came from to make the plastic that made the case. So they went back through. We found hundreds of different suppliers. We managed to trace all of the recycled materials, and the QR code at the top is also is a link to the digital product passport itself, so that you can see, if you want to scan it, you can find all of the different, go back through, and it will show all of the different suppliers and different levels of the suitcase. Essentially, yeah. What you can see on the platform in Circularise as Samsonite is different to what you can see on the public DPP. There are certain things that are confidential that cannot be seen on a public basis, but if logged into on the Circularise system, you have some access to them depending on what the person who provided that data allows other people to see on the platform. This is very useful in B2B cases where I don't want to share my information to the consumer, but it's necessary to share it to other businesses. This is a great way to do that. But it shows we can hide some of that data. It's not just an important thing is that it's not just for that final product. So something like the handle has its own DPP associated with it, and that is just added as another book to the bookshelf of the full suitcase passport. So you can kind of stack all of these different things together and get insights on different parts of it that make it easier to then make strategic circular decisions. Like if we want to remanufacture this suitcase, we know that the pull handle has all of its information available to it, so we can take it out of the old suitcase and put it straight in a new one, because we know we can verify how well it still works based on the information that we have on it in the passport. Another one that we've built is a demonstration battery passport. So being able to show, essentially, it's a passport that we built that aligns with the battery passport regulations. And we're constantly monitoring those and building them up, or building up the passports as we get closer to the regulation and being implemented. But yeah, we can show. Essentially, we have a relatively standard offering for that. And then we've also done use cases for something like in construction materials, looking at different pulps from Teijin for the different kinds of fibers that they have, being able to show that it's made from post-production waste and proving the reintegration of that waste into new materials. So there's a lot of different ways that these kinds of systems can work, essentially. So with that, I will kind of open the floor to some questions. I think we have about 8 or so minutes. And yeah, thanks for sticking through with that. I don't know if, can I see in the chat? I don't see anything, or I think there's also a Q&A session. Yeah, or I think at this point, Elena, if are people able to unmute?
Yes, I think people can unmute and ask directly. So Ivana, if you want to go ahead.
Yes, first of all, thank you for this very, very great presentation. I have one question. When we're seeing the digital products passport in terms of industry level, like where we can see the highest circular potential, where do you think is it good how the EU regulation is starting with batteries and going on textiles? Like which industries do you think are the one that should be priority to implement the digital product passport? And the second question is with this slide about data carriers. I really loved how you showed us everything from QR codes, watermarks, and everything. What do you think, or do you have any experience like which of these data carriers are better for which industries? Like I know for textile, for example, you cannot use the QR code because when you wash the clothes, they will be thrown away, so you don't have the
Yeah.
information at all. Like, do you have like here something more to tell about the data carriers in terms of which industries are best? So thank you very much.
No worries, thanks. And those are also two really good questions. So the first question was on, the for the on I can answer for the second one. I think that the different data carriers, in most cases, I think that something like a QR code or a barcode is going to be just fine because the product is going to be relatively well protected. It's going to be, and also relatively complicated. So being able to find the QR code and easily apply it in a way that doesn't add additional complexity for the manufacturer is going to be probably the easiest and best way to do it. There's no need to overcomplicate it in those situations. So something like a battery or a laptop, like most electronics, I don't see why you wouldn't use something like that. Where the data carriers kind of fall down, especially those surface level ones, is in something like recycling. I can see also for textiles, as you mentioned, that would be quite difficult. Because as things get washed or as consumers use, especially something like packaging, there's no guarantee that that QR code or that data carrier is going to survive to the point where the recycler needs to be able to read that information. So in those kinds of cases, I can see something else coming up. The idea of the data carrier being something like a material tracer is really interesting from a conceptual and very promising level. I can see that becoming really complicated as different material streams combine, and being able to combine all of those together, that would be quite difficult. But I think that there's probably room for something like passive NFC, especially if you can build wires into those are generally more flexible. They're a little bit more robust. So something like that, I can see being quite useful for textiles, as an example. To take the other question on, do I think are we rolling out the right things at the right time? I think it makes a lot of sense to do this on something that is a relatively complicated component of a larger product. So something like a battery that is a very large and complicated component of an EV would make a lot of sense, because that's a very high value. There's a lot of value stored in that, and there's a lot of value that is that's built on top of just the value of the commodity materials themselves. Being able to say, if we can take this battery and we can take it apart, and we can take it from a large EV battery into a stationary grid battery, and then take out the cells and use those in e-bikes, like being able to slowly take it apart component by component, and kind of like go back through that nest of DPPs, is something that's very valuable. It's very difficult to set up. So I think it probably, I don't have a problem with them using the DPP at the start for batteries. I think getting it in one situation like that, with a very well-defined use case, is probably a really good idea. And then expanding into something that's a little more complex, like textiles are in multiple different industries and have multiple different uses. Something like construction products becomes very difficult, because you have different kinds of materials coming from different places, and I can see why they would want to stagger the release and try and solve some solve some early questions and then hit some of the harder stuff later.
Thank you very much.
I think, is that Lisa? Has her hand up? Yeah.
Yes, there's a question from Lina.
Lena, sorry.
Yeah. Hi. Thank you, Lina Plataniti from Norsus, from Norway. I have like two questions actually. The first is like it is a bit practical. You refer to the data and the data sources. Do you know if data source it is a requirement to include the data sources as well in the digital product passports? This is like just a small practical thing. And the second question is about where all this data, where is it saved? Is there like a European infrastructure to save this data of the digital product passports? Because it has to be like information, as you said, across the supply chains. So, and what happens if there's a change like upstream in the supply chain? How are the data updated? And yeah, so these practical things which are not clear. Other than that, it was very interesting presentation. Thanks a lot.
Thank you. I think so. For the first question, the data sources, as far as I'm aware, are not necessarily required for that. They can help. They may be part of it. May end up being part of some of the due diligence requirements, and being able to prove and verify that data came from certain sources could include those data sources. But as far as I'm aware, just the values are necessary for now. In terms of how it is stored, I think that is, at the moment, a lot of that is, I think, still a little bit up in the air. There are some things like the EU is creating a battery registry where they want to be able to kind of link to all of these different passports that allows people to see them. But generally, it's on the manufacturer to provide some of the storage and also some of the, and also in some cases to provide a backup. It's likely that in these kinds of cases, I can see the manufacturers providing providing either the backup or the original, but not both of these systems, and the backup would go to, say, a DPP provider or some third-party provider. As far as I'm aware, there's not a ton of EU infrastructure being built, but I haven't spent a ton of time looking at that, so I'm not 100% sure on that. So I would can't say with any great confidence.
Yeah, no, thank you. It was just practical questions. Yeah. Okay, how it will be practically implemented in that sense. Yeah, but thank you.
We also have a question in the Q&A chat. I don't know if you want me to read it or you want to read it aloud yourself.
I can read it as well. I'll read it also for the people and for the recording for later. From Manjuri. Can you brief on who is responsible for the DPP? Like, for example, the economic operator, with some real examples like a battery getting imported from China to Europe. China has its own DPP network laws now. They're a little bit more restrictive on sharing battery-related data outside of China and controlled by the government. Have we come across that issue and ideas on how to solve this? In these kinds of instances, it can be quite difficult to share data across different geographies and different regulatory environments. There are ways to do this that allow you to create to share, again, those focusing on what the insights are that people want in the different regulatory environments instead of necessarily the data itself. So there are methods by which that can be done. I think the example that I provided with what Circularise did for Samsonite did work across different borders, and I think there was it generally tended to be, or that tended to be relatively open. So there wasn't that big of an issue there. But I'm aware of some methods by which that can happen. I'm not confident that I'm able to share them because they are worked on at Circularise at the moment. But it's becoming more difficult. But I think that there will be solutions for that. But I don't have a ton of them available at the moment, fortunately.
Thanks, Daniel, for replying to the questions. It's a bit over 12, so I think we should wrap up. I just wanted to thank everyone for joining, and thank you for sharing your expertise with us. I hope everyone found it interesting and learned a bit more about digital product passports. Thanks everyone, and thank you, Daniel.